Today's lesson is 9.2.2, Operations with Radicals. A quick introduction to radical expressions can be found on page 489 of the class textbook, Discovering Geometry, an Investigation Approach by Sarah. Irrational numbers. The set of irrational numbers is a set of numbers whose decimal representations are neither terminating nor repeating. An example of this we are already familiar with is pi, of which we know is 3.1415926535897, and so on. Now let us define several terms. Square roots. The square root of a non-negative number n is the positive number that when multiplied by itself gives n. This is represented in this form of square root of n. A perfect square. Perfect square is a number that is the square of a whole number. Examples: 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Note the square root of a perfect square is a whole number. And radical, square root of n includes the radical sign and radicand. Now let's simplify square roots. Factor the radicand in this case, so that one of the factors is a perfect square. If a radicand does not have any perfect square factors, the radical cannot be simplified. Let's start by attempting to simplify square root of 75. Well, square root of 75, this also equals the square root of 25 multiplied by 3. So square root of 25 multiplied by the square root of 3 can be simplified to 5 times the square root of 3. Square root of 500. Well, I know that's the same as the square root of 100 times 5, which equals the square root of 100 times the square root of 5, which is equal to 10 times the square root of 5, and simplified. Square root of 17, well, 17's prime. I could write that it equals the square root of 17 times 1, which equals the square root of 17 times square root of 1, which is just equal to 1 times square root of 17, or square root of 17. So even if I go through the work with a prime number, I will still remain with a factor or a radical that cannot be simplified, leaving square root of 17. Now let's take a look at multiplying square roots. The product of the square roots is the square root of the product of the radicands. So let's just multiply so we can start understanding this. So if I were to multiply square root of 2 times square root of 5, this is the same as square root of 2 times 5, which is equal to the square root of 10. Square root of 7 times 7, well, that's equal to the square root of 7 times 7, which is equal to the square root of 49, which, as we know, is equal to 7. And then 6 times 12, well, that's equal to the square root of 6 times the square root of 12 is equal to the square root of 6 times 12, which is equal to the square root of 6 times 6 times 2, which equals the square root of 36 multiplied by the square root of 2, which in the end equals 6 times the square root of 2. Now, dividing square roots. The quotient of two square roots is the square root of the quotient of the radicands. Here's some examples using this. Dividing. Well, square root of 75 divided by 3 is also equal to the square root of 75. Sorry, the square root of 75 divided by square root of 3. Square root of 75 divided by square root of 3 is equal to the square root of 75 over 3, which equals the square root of 25, which equals 5. Now the square root of 90 over the square root of 2 is equal to the square root of 90 over 2, which equals the square root of 45, which equals the square root of 9 times 5, which is equal to 3 times the square root of 5.